page 29. We're talking all about circles. Okay, so for number 146, we have a lot of different questions all crammed together under number 146. So each one I'm going to talk about separately. Now the directions say find the value of the requested component in each example. All right, let's zoom in. So for this first one, we're trying to find the measure of arc ST. So when they say measure of an arc, they're talking a degree measure, not a length, but a degree measure. So they're asking for ST, which is this section right here. Couple of things that you need to notice in your diagram. So again, look at your diagram. Let's notice a couple of things here. First, I want you to notice that SU is a diameter. It's passing through the center of your circle. So this diameter here is cutting your circle in half, which means to the right of that diameter is going to equal 180 degrees. And same thing to the left. This section here will equal 180 degrees. Now we're going to focus in on the right because that looks like where our arc ST is and where our 61 degrees is. Now let's take a look at that 61 degrees. 61 degrees is the measure of angle TSU. So I'm just going to go ahead and I'm going to highlight that angle for you. This angle is called an inscribed angle. It's called an inscribed angle because the corner of the angle is on the circle. So right there at S, that's the vertex of your angle. It's on the circle. Now when you have an inscribed angle, you want to figure out, well, what is the measure of the arc associated with that angle? The arc that's trapped in between the two sides that make up that angle. Well, as you pull your inscribed angle forward, as you pull it forward, you double it. So you multiply it by 2. Only when you see that the vertex of the angle is on the circle, you're going to double it as you pull it forward to figure out the measure of arc TU. 61 times 2 is 122 degrees. Now that's the measure of this arc TU. We want to figure out the yellow arc ST. Well, notice that the 180 is the two arcs together, the yellow one and the 122. So to figure out the yellow one, we're going to do 180 minus 122, and whatever we're left with is the measure of the yellow arc. So 180 minus 122 equals 58 degrees. So 58 degrees is the measure of arc ST. So two important things to note here. Inscribed angles, as you pull them forward, you're going to double them. Also, diameters, like SU, are going to cut your circle in half. So it's 180 to one side, 180 to the other. All right, let's take a look at the next problem. Now this next one, again, look at the problem, observe it, and then notice that we have an inscribed angle again. Notice that A is a vertex on the circle. So thinking back to what we did in the previous problem, if we had the measure of angle A, we would double it as we pulled it forward. But in this problem, they're looking to find the measure of angle A. You don't have it. So let's think about how we're going to get that. Notice that the two sides of angle A trap this arc in between them. So this arc of 158 degrees is directly associated with angle A. Now, to figure out what angle A is, you're going to take the arc, and let me go ahead and get rid of this a little bit. Okay, you're going to take the arc, BC, and as you pull it back towards your vertex, instead of multiplying by 2, you're going to divide by 2. So in the calculator, do 158 divided by 2, and you're going to get 79. So in this case, since we were given the arc, to figure out the angle, you have to divide it by 2 to get back to that angle. Okay, and that's our answer, 79 degrees. Let's take a look at the next one. Okay, find x and y. Now looking at my figure, I notice I have this inscribed quadrilateral. And usually, one thing that you have to know with inscribed quadrilaterals is that opposite angles add up to 180 degrees. So whatever this angle y is and whatever this angle is here, they should equal 180. But I don't have any angles across from y. And I don't have an angle across from x. So I can't use that property of inscribed quadrilaterals where opposite angles equal 180. I have to think something else. Okay, so I'm going to go back to the drawing board. I'm going to erase all this. And now let me think. Okay, if I'm looking for angle y, I'm just going to go ahead and trace the two sides that make up that angle. And I notice that y is an inscribed angle. Again, the vertex is on the circle. So if I can get this arc that my angle y is cutting off, if I can get that arc, as I pull it back to get angle y, I'm going to divide by 2, just like we did in the last problem. As you pull the arc back, you divide by 2. Okay, we'll look at this red highlighted section. It's 108 and 104. So put those together, and that's going to give me the entire arc. So 108 plus 104. 8 plus 4 is 12. Bring down the 1. 1 plus 1 is 2. So it's 212 degrees for the measure of this red arc. So as we pull it back, we're going to do 212 divided by 2. And we're going to get 106 degrees for angle y. 106 degrees. So that's the measure of angle y. Let's see what we can do with angle x. Again, I'm going to clear off my board a little bit here. Okay, so angle x. Again, I notice the angle x is an inscribed angle. The vertex is on the circle. So I'm going to trace the two sides that make up my angle. And I note that if I get this green arc here, which is the part of the circle's outline that's tracked between the two blue sides of angle x, if I can get this green arc, as I pull the measurement back towards the inscribed angle, I'm going to divide by 2. So again, noticing that green outline, it's made up of 75 and 108 together. So let me add those together. 108 plus 75. Do that one on the calculator. 108 plus 75 equals 183. So 183 is the measure of the arc. As I pull it back, pulling it back towards the angle, I'm going to divide by 2. And I get 91.5 degrees. Okay, so that's the measure of angle x, 91.5 degrees. So we have x and we have y. All right, let's go to the next one. Find the measure of angle G. Okay, let's take a look at the diagram. All right, angle G is right here. Again, it's an inscribed angle. I'm going to look at the two sides that make up that angle. Here we go. And the part of the arc that's in between the two blue sides is right here. I'm going to highlight it in yellow. So if I can get that yellow highlighted portion, I'm going to pull that measurement back, dividing it by 2, and I'll get the measure of angle G. Okay, so let's figure out what that yellow piece is. Now, I don't have the two yellow pieces. What I do have is 70 and 120, which make up the rest of the circle. So I need to think about, well, what is the entire circle equal to? An entire circle is 360 degrees. If I subtract 70 and I subtract 120, if I cut these out, take them away from 360, all I'm left with is the yellow portion that I want. So let me do that on the calculator. 360 minus 70 minus 120 equals. Okay, so 170 degrees is the measure of the yellow arc. So as I take that yellow arc and I pull it back, I'm going to divide it by 2. and I get 85 degrees for angle G. So 85 degrees is the measure of angle G. So we did a lot of practice with inscribed angles. Let's take a look at the next one. All right, now notice this one is different. The vertex of the 135 degree angle is at the center of the circle, not on the circle. This one's different than all the other problems. When you have an angle that has its vertex in the center, that angle is equal to the arc that it intersects. So if 135 degrees is the measure of angle C, then 135 degrees is the value of x as well. Really straightforward. So if you have a central angle, an angle where the vertex is in the center, it's the same as the arc that it cuts off. So the measurements are the same. So for another additional example, if this here was 70 degrees, then this red arc here would be 70 degrees. Because my vertex is in the center, not on the circle, not on the outline of the circle, but in the center of the circle. Okay, let's keep going. Okay, so for this one, find the area of the shaded region and the length of the minor arc to the nearest hundredth. So we're looking for area of the shaded region, so the gray shaded region, and the length of the minor arc. Okay, let's start with area. So we're looking for that gray section. Now we're only looking at 135 degrees of the entire circle. Now I know how to find area of the full circle. Well, how do I find just that portion? There's a very standard formula to use when you're looking at just a portion of the circle. And it looks like this. Take your degree measure, your central angle, divide by 360. And since you want to find the area of the shaded region, you're going to multiply by area of the full circle. Whatever you get is going to be the shaded portion. The shaded sector. Okay, so let's take a look again. Our degree measure, our central angle here is 135 out of a total of 360. Now in your calculator, 135 divided by 360 is going to give you a decimal, but that decimal is really a percentage. This shaded region is about 37.5% of the entire circle's area. So what we're doing when we're multiplying by this fraction is we're taking 37.5% of the total area. That's what we're doing. That's a conceptual understanding. Okay, so 135 over 360 times the area for a full circle. They didn't give you the area for the full circle, so you have to figure it out. Replace area formula with pi r, which in this case is 7, squared. And you do this all in the calculator, and what you get is the shaded portion, the shaded sector area. So one more time. 135 divided by 360 equals times the pi times the 7 squared, which is 49, equals. So it's 57.73 if we're rounding to the nearest hundredth. So we're going to write 57.73, and our units are centimeters squared because it's area. Now, for the second part of this question, they're asking you for arc length. So they're asking you, how long is that section right there? I don't want the entire circumference. I just want that little portion. The formula is going to look very similar, except where it says area of a circle, you're going to replace that with circumference of the circle, because you want just a portion of the circumference. So let's go ahead and do this now for the arc length. So same process. You're going to do degree measure over 360 times the circumference of a circle, and that's going to give you arc length. So our degree measure is 135 over 360 times the circumference of a full circle, which is 2 pi r, So 2 pi times 7, and that's going to give you the arc length. All of this is in the calculator. So to your calculator, 135 divided by 360 equals times 2 times pi times 7 equals. So about 16 point, if we round to the nearest hundredth, the 9 is going to round, actually it's going to stay the same. So 16.49, I thought it would round up, but it doesn't. 16.49 centimeters long is that yellow arc. 16.49 centimeters. If they asked you for the measure of that arc, it's 135 degrees, because that 135 is a central angle. But they didn't ask you for the measure of the arc. They asked you for the length of the arc. So that's when you do this formula here. So 16.49 centimeters. Okay, so a lot of stuff with this question. Just to recap, we worked a lot with inscribed angles. We worked on central angles. And then we did sector area and arc length. Okay, so a lot of circle stuff. Let's keep moving. Number 147. Find the circumference of the circle if the area of this shaded region is 48 pi. Find the exact value for the circumference of the circle. Okay, let's go to the ask of the question. Find the exact value for the circumference of the full circle. Okay, exact value. For me, that means you're going to keep the pi. You're not going to multiply it in. You're going to keep it in terms of pi. That's what I think. Okay, so circumference of a circle. Let's focus. How are we going to get circumference of a circle? Well, the formula for circumference of a circle is 2 pi r. Look at all we need. We just need the radius. Let's look if we have the radius. Well, no, we don't have it. We're going to need to solve for the radius before we can use our formula to get the circumference. Now let's think, what did they give us? They told us that 48 pi is the area of the shaded region. So 48 pi is the area of this gray section right here. Well, that doesn't really give us radius right away, but maybe we can work that backwards to figure out r. Okay, so let's think. How do you get area of a shaded region? Well, we just did it before in the previous problem. To get area of a shaded region, we do the degree measure over 360 times area of a circle, and that gives us the shaded region. So let's see. Let's see if we can go ahead and break out this area formula and see if we can solve for r somehow. All right, so our degree measure is 120 over 360. Our area of a circle, they don't give it to us. They only give us area of the shaded region, right? Not the full circle. So I'm going to replace the area of a circle with the formula that gets you area of a circle, which is pi r squared. Now notice this is where the r appears that we need. So let's keep going and plugging into the formula. Equals. Now the shaded region, well, that's the 48 pi. That's what we have. So I'm going to plug in 48 pi. Now notice the only variable is r that we've highlighted. So we can go ahead and use our algebra, solve for the radius, and then our last step would be to plug in to get the circumference. Let's go ahead and try to do that. I'm going to focus in on this. Okay, first step. If I have pi's being multiplied on both sides, I can cancel out the pi's, which makes it into 120 over 360 times r squared equals 48. Now, to get r by itself, we're going to have to start working with that fraction. Let's start by getting rid of the 360. I'm going to multiply both sides by 360. On the left, it cancels. On the right, 48 times 360 is 17,280. 17,280. bring down the r squared, bring down the 120. Okay, now next step, I'm going to divide both sides by 120. So now I have r squared equals 144. And now I just want the radius, not the radius squared. So I'm going to square root both sides. The square and the square root cancel. So r equals the square root of 144, which is exactly equal to 12. Okay, so I have my radius. Perfect. That's all I needed to get the circumference. So now refocus. We're going to go ahead and plug in r into our formula so we can get the circumference. So circumference equals 2 times pi times 12. Multiply 2 and 12. Circumference equals 24 pi. Now, if I multiply that in, I'm not going to get an exact answer when I write it down. I'm going to have to round somehow. So this is my exact answer. It's 24 pi units. So 24 pi is exact. 24 pi units. I don't know if it's centimeters or inches or whatever it is. 24 pi units. Perfect. We're done with that question. Now to recap, what happened? We wanted to get circumference, so we wanted to use the 2 pi r formula, but we didn't have the radius. Instead, we had to grab the shaded region, 48 pi, write down the formula that would have given them 48 pi, work it backwards, and solve for r. Then we were ready to go ahead and plug in. Okay, let's go on to the last question on this page. 148. Find the equation of a circle with a diameter that has endpoints at negative 112 and negative 1, negative 8. Okay, the ask of the question. Find the equation of a circle. Okay, let's focus in on how you need to present the final answer. The equation of a circle looks like this. X minus h squared plus y minus k squared equals r squared. The only two things that you need in order to write the equation of a circle is your center and your radius. If we can get those two things, we can write the equation of a circle. Now, what did they give us? They gave us 2 points, which are the endpoints of our circle. Now think about what they gave us. If we have a diameter, so picturing what's happening, if I have endpoints of a circle or endpoints of a diameter, and my circle goes around that diameter can let me find not only the center, but also the length of the radius. So let me go ahead and look at the graph and see if I can come up with the center and radius to this circle. Okay, if I have negative 1, 12 as 1 point, let me zoom in. Negative 1, 12, well, that's going to be a little bit off the graph, so we're going to go right here. And then our second point was at negative 1, negative 8. So now we're here. Now our diameter looks like this. Not a great line, but okay, so that's the diameter. Now picture your circle is going to go around it somehow. Definitely not exact, definitely not accurate, just giving yourself an idea of what's happening. What we need to find is the center and the radius. So the center would be the midpoint of this diameter. So we just need to find the halfway point. If we count how many boxes it is to get from negative 8 all the way up to positive 12, you're going to find that it's 20 boxes. So halfway is 10 boxes. So starting from the bottom, I'm going to count up 10. Go up 8 and then 2 more. So right here, that's going to be the center point. Negative 1, positive 2. So my center is at negative 1, positive 2. Now my radius would be the length here from the center to a point on my circle. Since it's really easy to count the boxes vertically, I don't have to do much work. If it was a slanted or diagonal line segment, I'd have to do the Pythagorean theorem or the distance formula to figure out that length. But luckily, up and down, super simple. So halfway point is 10 boxes, so my radius is 10. Below it's 10, and above it's 10. Those are the two things that I needed. So going over to where I've written out all my information, -1, 2 is my center. It's that halfway point, the midpoint of the diameter, and my radius is 10. So keep in mind, you could have done midpoint formula here. If you're not a great visualizer, you could have done the midpoint formula. Now we're ready to go ahead and plug in. So plugging in -1 and 2, always keep in mind you're going to switch the signs when you put it into the equation. So it's going to be x plus 1 squared plus y minus 2 squared. And my radius is 10, but then I have to square it. So 10 squared is exactly equal to 100. So equals 100. This is my final equation. And that's something that we're used to seeing. Okay, so just to recap, when they give you endpoints for the diameter, your midpoint is the center of the circle. And that's the first thing that you need. And then the radius is just the length that goes from the midpoint to one of your endpoints. Luckily here we could just count the boxes and it was 10. So that's how we came up with both pieces of information, threw them into the circle equation, and now we are done with this page.